Hi everyone. Thank you for joining us in this webinar today. We all know that capturing buildings with drones is an ever-changing landscape. So today we're going to share a few insights with you which will help you to streamline the process, including ways to use AI to make your life a lot easier and your building inspections a lot faster. This is going to be about a 45-minute webinar. A recording is going to be available to view afterwards. For the first 25 minutes, Varun is going to join us to share a presentation, and then we're going to leave about 15 to 20 minutes at the end for the Q&A. If anybody's got any questions during the presentation, instead of raising your hands, if you could just please make a note of them, and we'll cover it in the Q&A at the end of the session. If that all sounds good, over to you, Varun.
Thanks, Nikki. As Nikki mentioned, today we're going to be talking about capturing buildings with drones and AI. Whilst it's really interesting to be fascinated by drones and what they can do, fundamentally drones are a data operation, much more so than we think. It's all cool to see those propellers start off and kind of seeing that drone in the air, but over time you realize that actually everything is about the data. And more than thinking of the drone as an aircraft, it should really be thought of as a flying camera. Um, and if you start thinking that way, you need to kind of also then think, well, who is actually using that data? Because if the data doesn't get used, it's not useful. And if it's not useful, then you can't justify the cost of capturing it. And so when we think about who's going to use the data, I think the most obvious for us is actually thinking about the people that are going to be using the data. So this could be your internal stakeholders, it could be your clients, it could be, your partners. And that's like the easy bit to understand who's going to be using the data. But I think if we think about it from a more high level perspective, there are two other things that will be using the data. One of them is the CAD and BIM software that the data is going to flow into. So if you're here today from a architecture, engineering, or a construction firm, you will be using BIM and CAD heavily in your organizations. Or if you're from a drone service provider organization, your clients will be using CAD and BIM heavily in your organization. So thinking about how that data flows into CAD and BIM or other software is actually really important. And then the third component that is increasingly becoming interesting is actually how does the data actually flow into things like AI, and how does the AI actually make decisions based on that data in the future? So I think that's another consideration that we haven't had for the longest time. So, needless to say, that since you have these two other components that we barely think about, those two components require structured data. So humans can be really good at, understanding unstructured data. So if you give humans a whole bunch of images, maybe they can piece together what's happening with a building. But if you give that same data to an AI system, or if you give it to a BIM or a CAD system, those systems are not going to like unstructured data. So I think given that's the premise, one of the things that's very clear to me and hopefully is clear in the industry is that structured data is key. But you then end up with this challenge that if you want to capture structured data, the built world is not sort of built to capture structured data. It's actually very complex and it's very unstructured. You've got all sorts of buildings. You've got tall buildings with, facades made out of different materials. You've got towers that are skyscraping. You've got cooling towers that have parabolic shapes, and you've got bridges that have, both their kind of top deck and the underside that needs to be inspected. And so the built world is really complex and unstructured. So what I want to do today is actually I want to give you some strategies for structure. I want to give you some known rules of thumb that can be handy when you're capturing data for building envelopes, for built structures, that can actually essentially give you at least a framework to operate with. So even if you're not using, hammer missions, you're using whatever tools you prefer, having that sort of structure will really help you in capturing high quality data. So I think the first strategy is to sort of divide and conquer. So I think when we think about capturing a building, we generally think about it in totality. So we think about it, from the full building envelope perspective. But the reality is that your drone only has limited battery life and it only has certain amounts of SD card space. So you want to be able to actually divide the building into manageable components and then capture those components independently. However, you want to make sure those components have the right sort of structure and then they sort of fit with each other in the right way so that you can actually bring them all into one project. More specifically, what I'm going to do is I'm going to actually go through some buildings and I'm going to talk about what's the best way to capture some buildings. So over here is an example of a short building. So a building that is shorter than it is longer. So if you look at the geometry of the building, you've got more length and width in this building than you've got height. And so a building like that, a good strategy to capture that sort of building is to actually capture the top of the building. So these yellow points that you see on the screen is essentially each one of those is basically a point or basically an image taken by a drone. So a drone flew and took an image of that particular point. So if you think about of that particular point, so if you think about in this particular example, you had the roof of the drone captured at one altitude, and then you had these orbits that were flown around the building to capture the facade of the building. So for a building like this, if the goal is to create, if the goal is to essentially map the entire building envelope, this sort of strategy can work really well. So you don't have to sort of like do every single facade separately. You can essentially do orbits around the building, and you can do the roof of the building. However, if you're looking at really tall buildings, so buildings that are taller than they are wider, taller than they are long or wide, you need to sort of like get more clever. So once again, you need to sort of divide the building into different components. So you need to think about the roof, you need to think about the facades. But one of the mistakes that we commonly see in tall buildings is that people would generally go out there and they would capture the roof and then they would capture the facade, but they wouldn't capture this orbit in between. And this orbit in between is really important because you want to make sure that the images that you capture for a tall building overlap with each other. And this orbit also needs to be at a gimbal angle so that you're able to sort of see the right areas that tie the roof and the facade of the building together. Now, it's easier said than done. So hopefully I can sort of show you some examples later on in terms of like how this is actually put into place. But again, with tall buildings, you need to have this sort of framework in mind that if you want to capture the entire building envelope, you need to make sure that you have your roof and your facade, and then you need to have these overlapping images in between. Um, Towers. So towers are also really interesting. So you will sort of notice that in towers, you generally want to fly around the tower, taking images in concentric circles. This is because it sort of promotes overlap and also follows the geometry of the building. So one of the things that you will notice is that, you know, whether it's a tower, whether it's a tall building, or whether it's a short building, all of those examples are actually all about capturing the geometry of the building and sort of forming this convex hull. You want to make sure that you're actually following the geometry of the building with the right overlaps, and that's what's going to give you the best quality images to be able to model the building envelope. And then you've got bridges. So with bridges, again, you want to follow the geometry. So a bridge doesn't really have a roof. It has maybe the top deck and maybe it has all the sort of supporting structure. But you want to sort of like think about it in the same way where you have your horizontal capture for the top bit and then you have your facade capture for the underside of the bridges. And you want to be able to tie that together as well. So again, getting some good overlap between those images is extremely important. So what I'm going to do is I'm actually going to switch to some actual projects to show you sort of how what that looks like. So for example, I've got the very first sort of short building that I talked about earlier. And you can sort of see that on the left-hand side over here. And if I was to sort of bring up all the images that we used to capture this particular project, is all the sort of dots that have just come up on the screen. Those dots represent where the drone flew and took an image. And as I mentioned previously, so this was created by having a top capture and then a side capture for making sure that you've got the facades properly captured for this particular building. And one of the things you'll notice is that if I click on any one of these images, they have a certain gimbal angle to them. So the gimbal is not looking straight up, it's actually looking at an oblique angle. And because the facade is not big enough, you're able to actually see the entire facade in one image. And so whilst we had 3 different orbits for this particular building, one orbit could have been sufficient. Because you're actually able to see the entire facade through one orbit. And so this is the thing that's really important to keep in mind, that you don't need to capture every single facade in its entirety. You just need to capture one orbit if you can see the entire building. So that's really important to keep in mind. The next example I have is actually of a tall building. So this was facade captured. So basically what you which you can do for a tall building, is to actually just fly vertically and then capture the buildings essentially vertically with the images overlapping with each other and then following a vertical grid in front of the building. Now, to improve this, what you could do is you could actually fly not just in a left to right manner, but also in a top to down manner. And you can sort of like combine both of those images together to create an even better 3D model. But this is just generally overall a good practice to be able to sort of like create this facade map. And if you wanted to do so, what you'll notice is this is just one of the facades, right? So if I go to the left, you'll sort of see that the quality of the model deteriorates over here because there are no images taken on the left-hand side of the building, which is completely okay because in this project, only this particular facade was relevant. But if you wanted to capture the whole building, what you could do is you could actually add an orbit at the top, and you can add essentially you can add an orbit on the top and the roof, and then you'll be able to sort of like add images for basically the entire building, which will allow you to sort of facade capture the entire building. The next example that I have is of the tower that I showcased. So this one essentially is captured using orbits. So this was only 2 orbits. So if you think about it, the number of images was actually quite tiny. But you can basically capture the entire orbit, entire tower by just having these 2 orbits around the tower and having that gimbal angle so that you're looking into the tower as opposed to looking at the sky. So one of the things for towers is really important is that you never add horizons. You never want to have this vantage point for your tower because that will cause all sorts of issues because sky looks very similar. What you want is you want to have the images looking down on the tower in a gimbal angle that is pointing down. That just allows you to be able to get the right features into your model. The last projects I'll show you is the bridge. So with the bridge, the capture was done predominantly following the length of the bridge, and then essentially adding the facade images. So this was done in both 2D and 3D. So if I was to sort of switch to 2D, you'll notice that actually the flight path was basically a double grid, with the second part of the grid actually focusing on the underside of the bridge. So these are some of the projects that I've talked about, but the question is, why do we have to do this? Like, why is this even relevant? But if you ask that question, it's because fundamentally these 3D models are created by a process called photogrammetry, which I'm sure people in the audience today are familiar with. And photogrammetry is a very interesting and very specific technique to create 3D models, which require this sort of structure. They require that you've got good overlap between images. It requires that you have overview shots, and it requires that you have the right sort of distance to the structure. I'm not going to go into the fundamentals of photogrammetry here, but I think keeping some of these rule of thumbs in mind and then understanding what photogrammetry actually does can be really, really helpful in understanding how to capture high quality data. Right. So the strategy 2 that I'm going to talk about is actually capturing multiple data sets. So, well, it's all good to capture 3D modeling images, but if you're interested in inspections, you really want to be able to see the details. And so when it comes to actually thinking about your 3D modeling and inspections, we actually recommend that maybe you need 2 different data sets as opposed to 1 data set. And maybe you need a data set for your 3D modeling that gives you the context of the building. And maybe you need another data set that gives you the inspection images. So now these 2 things are actually completely at odds with each other. So for 3D modeling, you generally need images that are at an overview, looking at the building from a distance. And for inspection, you really need these close-up images. Images in photogrammetry or 3D modeling requires overlap with each other, so you need to make sure they have structure. Whereas images may or may not overlap in inspection because you're really honing into certain areas that might be error prone or issue prone. Images must follow the building geometry. So this is true for 3D modeling, as I've sort of showcased in some of the projects before. And it's typically flown with automation because it's very hard to sort of like get the right overlaps together, even though we do know of some partners that have amazing flying skills can actually create the same sort of structure by flying manually. So if that's your cup of tea, go for it. But automation can really help here. And then you've got the images that will cover the issue prone areas on the detail side of things. This could be manually flown. Now, if you capture 2 different data sets, it just allows you to actually get the best of both worlds, because you've got one data set that really helps you to get your 3D modeling images, and then you've got the other data set that really helps you to be able to get your inspection images. And if you're able to bring all of those together, what happens is you're able to actually um, what happens is that you're able to actually do both your 3D model for context, and then you have your inspection images. So to give you a concrete example of that, so here's a building that was captured for inspection. As you can sort of see, the condition of the building is completely deteriorating and requires a lot of inspection. And so whilst the 3D model is great, you maybe want to be able to focus and hone in on certain areas. So what was done was that you had these images that were used to create the 3D model, and then we added these inspection images on top. And so because we added these inspection images, we can still sort of capture and look at the facade of this building, even though the 3D model was created. And that just again allows you to go seamlessly between the two worlds of 3D and 2D, and just essentially have this sort of dichotomy at all stages. I've already talked about how you bring it all together. You need to think about your 3D images, you need to think about your inspection images, and then you need to like finally bring it all together so that you can have human plus AI analysis. And this is when I will sort of like transition a little bit more into AI. But let me give you a concrete example. So, for example, in this particular project, what we noticed was that you had this building and it needed to be inspected. And so basically, you can notice that this building had lots of issues. So it had issues around water ponding. So you can sort of see that lots and lots of water ponds are basically being created on top of the roof, and you can see those water ponds, which is great, and it has quite a few of them, which is even better. But what you can do is you can actually train an AI system to look for these water ponds. And so in this project, what was done was when this project was processed, we used the AI image tagging feature. And on the back end, we asked it to look for water ponds. And so it didn't only go and sort of like find create your 3D model and inspection images, but it found all the issue areas. If I click on any one of these images, you'll sort of notice that actually you have these sort of dotted squares that have been created in the image, which are essentially AI-based AI-based water ponds. And so it can sort of find all these water ponds for you. And you can essentially then use that for your next inspection. Now, you'll notice that it's not perfect, right? So it's gonna find most of the water ponds, but maybe it misses some water ponds, right? So maybe it's missed that one, or maybe it's missed that one. And so you can actually like still go in and annotate the ones that might have missed. So you can sort of like do that, but it's already saved you time to sort of mark up all the other water ponds that you needed to. And one of the things you can always see is that there are some images that have been AI annotated. So you can always sort of see that tag, which is AI water ponding. Very soon you'll be able to like approve or disapprove of them. And then you have your human-based annotation, which is more of a solid square, kind of tells you the human did this. So as a result of this, what you can now do is you can think about that you're training the system to look for water ponds. So the next inspection you do is looked at maybe like 1,000 examples of water ponds already. And so the next one you do is going to be even better. And the one after that is going to be even better. At some point, it's going to be just much better than a human looking at water ponds. So that's the incremental value that we need to think about when it comes to AI, because ultimately it's really helping us reduce the time, but also add a lot of value over time to our inspections. Right. Okay. That's pretty much it. I think one of the last slides I want to leave you with before we open it up to questions is to sort of think about your drone program or your drone operations more generally. So I think that if you think about your drone operations on two different axes in terms of what are you trying to achieve, there is this one axis of standardization. So to be able to get structured data, you need to have a structured process which allows you, which goes from data capture all the way to data sharing. So, you want to be able to capture your data the right way. You want to be able to verify it on the site. Maybe you want to be able to process the data in the right way. And then you want to visualize the data in the right way and then share the data in the right way. And then there are these sort of applications. Maybe one day you're doing an asset inspection. Maybe another day you're doing just a site map. Maybe you're doing measurements one day. Maybe you're doing annotations the other day. Maybe you're looking at a timeline of models over time. Or maybe you're looking at AI and reporting. And so all these applications, which you might have a project which requires one of these applications or more, but you will still have a standardized way of doing the work or having a standardized workflow. So what we see normally with drone programs is that if you have a standardized workflow from all the way from capture to sharing, and then you repeat the same workflow no matter what project you're in, and then you sort of cherry pick what you need for that project, that sort of like allows you to get the best of both worlds. You already have a standardized process, but then you're also able to scale your operations, and you're not sort of jumping from one project to the other, and you have the ability to be both scalable or versatile and at the same time simple because you've got your standardization in place. So that's generally our thoughts on how drone programs should work, or to be able to build efficiency at scale. Yeah, I hope this presentation was useful and sort of like enlightened you about a couple of new things on the building envelope capture. We are Hammer Missions. We've been doing this for a few years now, and we're based in London, and also coming very soon to the US. If you like the presentation, do answer any of the polls that we have, and I'm going to stop talking now and open it up for questions.